Okay. Want me to finish earlier?
Sure.
So pay attention. Pay attention. Okay. Last time we did finish the topic of two-lane highways with the example about its capacity, and in that example we saw how we can predict traffic for future years, which we also did with the freeway topic. And then we moved on to the topic of traffic control devices. What are traffic control devices? The objects through which we communicate with the drivers. And there are three types: markings, signs, and signals. Markings can be longitudinal, transfers, or object markers. Signs can be regulatory, warning, or guidance. Okay. We also talked about the requirements for an effective control device. And then we moved on to traffic signals. From now onwards, our discussion will continue about traffic signals. And we started with the type of signals, which were 9. Okay. So some two very important points about traffic signals. If you decide on an intersection, we will have traffic signals. Then the signals should remain operational throughout the time. You cannot switch off the signal. Okay, no signals should be switched off because it will confuse the drivers. They don't know what to expect when they come next time on the intersection. Okay, so to avoid confusion, we don't switch off the signals. Unfortunately, in Karachi they do. That's why we are always confused. Okay. Second thing is, no other sign should be used with the signal. Okay. No other road sign should be used with the signal. The most important, the most critical case is using a stop sign. Okay. Because the signal could be green and then you still have a stop sign. A green signal and there's a stop sign. Again, confusion, right? So these points indicate that the signal should not cause any confusion because of their operation or because of anything else you are using with the signal. There are some advantages of having a signal. The first advantage is if you have an intersection. And you have very high volume, the signal is the only control device which can handle high volume. Okay, so signal is the most appropriate device for high volume intersections.
What use is what about?
And high volume you shouldn't. Okay, but then you can see we have very high volume roundabouts, and you see what happens. Okay, so we are not saying signal will solve the traffic congestion problem, but it will be more effective than roundabout. This is what we are saying. Okay, traffic keeps on increasing, everything will fail in the end. Okay, but if you have an intersection, you are not going to replace it with a bridge, then a high volume intersection, then signal is the most appropriate device to be used. Okay. Signals can reduce the severity of, or signal can reduce the number of severe accidents. Okay, the most severe accidents are side-on and head-on. Okay, they cause serious injuries, right? They can cause even deaths as well. So these accidents are not supposed to happen with the signal because you are blocking the drivers from the other direction with a red light. So driver has a clear indication, not move or move. So these serious accidents are supposed to be decreasing. But some non-severe accidents can increase. What are those? The bumper accidents we have. Somebody hit you from the back. They can increase because of the confusion of the red light, the yellow light, for example. Yellow light. Or sometimes you are moving and the person in front of you is still finishing his message. So he is not ready to move. Okay. And you are also looking at your phone. So he is not moving, he is looking at the phone. You are moving, you are looking at the phone. This still you can have a bumper crash, a rear end crash, but they are less severe. They are considered less severe. Okay. Yeah. With signals, you fix the timing, right? If you have signals, you are fixing the time when it will become green and when it will become red and so on. Okay. So you may have signals which are very close to each other, and you can fix their timings in a way that greens are following each other. So you have green, first green, the second green after that, the third green after that. Okay. So what will happen? You pass the first green, next intersection green, next intersection green. Okay. So this is what we call as coordination. Okay, we'll talk about it later on as well. But with fixed timings of the signals, this can be achieved. You can fix the timing of the signals in a way that cars don't stop in a series of intersections. Okay, this is another advantage. On non-signalized intersections, if you have a minor movement, the minor movement can be movement from a smaller road. So there are very few people coming from there. Or it can be pedestrians. Okay, so you have a major movement, and then you can have one of these minor movements. These people from the minor road or pedestrians may not get a chance because there is no gap. They have to wait for the gap, right? If it's a roundabout, a stop sign, you have to wait for the gap. With high movement, there is no gap. Okay, so either you will keep on waiting, and if you become impatient, you will take your chance. With a smaller gap, let me go. Okay, then it is matter of life and death, right? Okay, not so. But anyways, you will take a chance which will not be safe. But with signals, signal will provide you the gap. Okay, a safe gap, enough which is good for you to move. Clear? So there is no chance taking on your behalf. Okay, okay, let me decide when to go. No. Signal will stop the heavy traffic, and it will give you a safe chance to pass. So these are the advantages of the signals. Then we have signal indications. We know the signal indications, we call them lights. Okay, they are calling them balls because of their shape. Okay, because of their shape. So like if you take out the light, it's actually a ball, a full ball. It's not circular only on the outside. It's a complete sphere. Okay. If you don't trust me, you can go and check. Huh? Sure? Okay. We will see after the exam.
They're going to ask us if it's a circle.
Huh?
They're going to ask us if it's a circle.
No, I will not ask you, but your trust is up till the date of the exam. Right? After exam, because this was wrong, how can I get this much? Why do we, got these marks and so on. Anyways. So we know we have green light, yellow light, red light, green ball, yellow ball, red ball. Okay. We know about them. Yellow is supposed to mean what? Yellow is supposed to mean what? Huh? Get ready. Okay. And it can also mean, now this is when yellow happens after red, right? This is a yellow after red. Get ready. And the other one? Slow down. Everybody agrees, right? Slow down. So do it. Keep it in your mind. Write it on the front screen of the car. Slow down. Okay. So there are two yellows, right? They agree. There are two yellows. One after the green and one before the green, right? Which one is more critical? The one before the red, because you are actually moving now. You have to decide whether I should slow down or stop or do what. Okay? And the first one you already stopped. Okay? So even if you start moving on yellow, there is no danger. The other people already have a red, and you are starting from stop position, so it's not critical. Okay? The other one is more critical. When the signal was green, now it has turned to yellow. So you are moving, maybe your speed is high, so your decision can impact someone. Okay, you can hit yourself or the other person and so on. So we will take the example, or we will talk about the other yellow, the one which is more critical, the one which is after green. Okay. Then we have a flashing light or a flashing ball. It can be flashing yellow or it can be flashing red. Okay. Now you may have seen flashing green as well. Right? Flashing green. We are not talking about that flashing single. That flashes for 1 or 2 seconds as a warning, right? Then it turns to something else. It doesn't keep on flashing. Okay? The flashing is not continuous. This flashing is a continuous flashing. Okay? So you may have seen there is one on have you seen Applied Science University on that road, on that highway, the one which is going towards Alba. Okay, they are coming from Citra Mall, we are going towards Alba. Okay, so they just before the pedestrian signal, they are flashing yellow. It doesn't change, keeps on flashing yellow. Okay, so we are talking about that flashing, which is flashing continuous, no other color, just flashing yellow or flashing red. That's it. Okay, so it can be this one as well. Then we have signals which are with the arrow signs. So you see when the signal becomes green, it has an arrow inside it, right? So it shows a straight arrow or a left arrow. So you know that this signal is only for this movement. If you have straight arrow green, that means only straight can go. And then you see a left arrow which is red, that means the left is stop. Okay, so arrow indications for specific movements. Side distance, okay, for the signals depending upon the speed. Okay, 85th percentile speed. This is a very important value for us. I mentioned in the spot speed topic as well as the cover time topic. So you can see when the speed increases, the side distance also increases. More speed, you need more time to stop, right? Okay, at more speed now you need more time to stop. So I should see the signal with more distance. Okay, clear? Now if the side distance is not enough, how do we increase the side distance? So I designed the road, my road has a 85th percentile speed of, let's say, 60 miles per hour, but my side distance is not 750. What do I do? What can I do to increase the side distance?
The distance is larger.
Distance is larger, I don't have any problem. Distance is less.
Add more warnings before.
You can add a warning, the signal after so many meters or so many feet. Okay, anything else to increase the side distance?
Larger signs.
Larger signs? We're talking about a signal, right? So you can add a warning sign, that's done. But what can I do with the signal to increase the side distance? Make it higher. Anything else?
So can you add
Huh?
Speed.
Ramps, speed bumps, okay. So I reduce the speed. Okay. What else? You may have seen sometimes we change the orientation of the signal, vertical to horizontal. Okay, and then we put it on top of the road instead of on the side. Put it on the top of the road. So all these things can improve the side distance. Position of the signal, height of the signal, putting a warning sign, putting a speed hump. Okay, all these are helpful to make sure the driver can see the signal with enough distance to stop. Signal components, we are talking about the signal timing now. Okay, we have already mentioned cycle in some of the previous topics. What is the signal cycle? From green to green, basically when the signal completes all the lights. When the signal completes all the lights, we call it a cycle. Cycle length is the time taken by the signal. So it's a time, we call it length. Okay? It's time, but we call it length. That's how people get low grade in traffic. Otherwise, it's very easy. You just do these things to make sure you get confused. Okay? You are here or somewhere else? Okay. So cycle length means the time which is taken for the signal to complete the cycle. within one cycle we have different intervals. What is an interval? The time portion of time in which signal light doesn't change. The portion of time in which signal light doesn't change. The signal became green, it's green interval. Signal became yellow, yellow interval. Okay? When it will change from yellow to something else, interval will end. Okay? So an interval is the time in which signal light or signal indication doesn't change. So we have yellow interval, we have red interval, green interval, right? These lights. Yellow interval is also called as change interval. So change and yellow interval mean same. Then we have something which we call as clearance interval. And I think you have an idea about it. You are coming towards a signal, signal is yellow. Okay, what do you do? You speed up, very good. And slow down.
For it to become red, so you can't pass.
Okay, so whatever you do. But let's say you were him, okay, and you went fast, your signal is yellow. So you cross the stop line. Okay, you are going at fast, you already decided I'm going fast, I will not stop. Okay, I want to pass. Okay, but you don't know when maybe you just crossed the stop line, now it's red. You cannot stop, right? Okay, so when it is red for you, is it green for someone else?
It takes time.
It takes time. You know it, right? Everybody knows. Okay, that's why you do these things. So it takes time. That time is called as clearance interval. The other name is all red. Clearance interval is also called as all red. Okay, means what happened? Your signal became red, and the next one will become green after some time. So it's also red. So all the signals are red. Okay, we call this as clearance interval, all red time. Okay, one signal has become red, the next one still did not become green. So this time is called as all red or clearance interval. You didn't know about that. You did?
Is it clearance? Because sometimes there's a jump from those.
Clearance, we call it clearance so that people like him can pass. He's already in the intersection. Okay? So he can pass. You have to go ahead quickly. Okay. Then we have a phase. What is a phase? Phase is a combination of three intervals: green, yellow, all red. You combine these three, we call it a phase. Okay? So green, yellow, and all red. Green, change interval, and clearance interval. Yellow is called change, and all red is also called clearance. So if you combine these three, we call it a phase. Okay? And what is a phase? It is the time which is allowed for one movement to pass. The total time in which a movement is allowed to pass. So you are allowed to pass during green, you are allowed to pass during yellow, and you are also allowed to pass during clearance if you are already in the intersection. Okay? Signal can be operated in three ways. There are three ways to operate a signal. The first one is pre-timed. In pre-timed, the timing of the signal is set at the design stage. The yellow time, the green time, all the intervals and phases are set at the design stage, and it doesn't change during the operation of the signal. Signal is installed, it will work according to the time which you have already fixed. Okay? Clear? As a design engineer, you should know, as a traffic engineer, you should know that traffic keeps on changing. Okay? It goes higher in one direction, then lower at some other time, and the other direction may follow reverse. Okay? So it's your duty to make sure that in different timings the signal has enough time to accommodate the movement. Okay, so you know in the morning north side has higher volume, so you will design the timing with more time for the north side in the morning. In the evening, you know south side has higher volume, so you design the time with more timing on the south side in the evening. Okay, but everything is the responsibility of the design engineer. Okay, he will fix the time, and according to the time, signal will keep on working. Clear? Okay. Another type of operation is semi-actuated. We have used the word actuated earlier as well. Actuated means connected with a sensor or working with a sensor. Actuated means working with a sensor, connected with a sensor. So we have semi-actuated and we have fully actuated. Semi-actuated means what? We have intersection of a major road with a minor road. We have intersection of a major road with a minor road. One of them has a sensor which is connected to the signal. Which one? The minor. Okay, why the minor?
That's it.
You said the major.
It has less volume.
Yeah, because minor has less volume, so the sensor will make the signal go red for the major if there is a volume on the minor. Otherwise, major is green. Okay, so most of the time the signal will remain green. So if there is no volume coming from the minor side, signal will remain green. If there is half an hour where there is no car on the minor side, half an hour is green for major road. Okay, so this is called as semi-actuated. Then we have fully actuated. So that means what? Semi-actuated means, yeah, when all directions have a sensor. Yeah, all directions are measurable. Yes. Okay, when all directions have a sensor. The signal in all directions is operating according to the sensor. Okay, so every direction can have a different green every time there is a meter. Clear? Okay. So pre-timed signal can work very well in any situation, provided that there is not much fluctuation of demand. Okay, the demand is not very high. Then pre-timed signal can work fine, no problem in any situation. Semi-actuated, I told you, intersection of what? Minor and major. Okay, so every time there is a car on the minor road, signals will become green for some time, and there is no other car, it will become red for the minor and will remain green for the major. So major and minor. Fully actuated on the intersection of two major roads. Fully actuated is always on the intersection of two major roads. Okay. We have examples for all these in Bahrain as well. Then we have signal coordination, which I already mentioned, right? Meaning what? Huh? No, signal coordination. So you have a series of intersections which are close to each other. So you fix the timing of the signal in such a way that the cars keep on finding green when they move. Okay, this is called as signal coordination. Clear? Okay. So, but it will happen when you have signals which are closer to each other. Okay, signals are 2-3 kilometers from each other. This will not work. You can do it, but it will not work. Okay, because of the variation. Okay. Now, to make signal coordination work, I have to fix an interval between the green of the first signal and the green of the next one, right? I have to fix an interval. So this one will become green at 0 seconds. The next one will become after X seconds. So this X is called as offset. Okay. So how do I calculate the offset? After how much time the next one should become green? It depends upon speed and distance. If you know the speed, you know the distance, then you know when to make the other signal green. Okay. So that time is known as an offset. Clear? Okay. Yeah. One more restriction with coordinated signals. All signals which are coordinated with each other should have same cycle length. So the total time of one cycle for each signal should be same as the other ones. Otherwise it will not work. Clear? So there are two restrictions. The first one was what? The intersection should be close to each other, not less. They should be close to each other. Okay, they should be closer to each other. Okay, and the second restriction is common cycle length. Okay, these two highways which I have mentioned, they have signal coordination, but you have to keep in mind, it doesn't mean that you are on this highway and you think that, okay, why I'm not finding all the signals green, is Dr. Onav's fault. No. Signal coordination can be in one direction and you may be in the other direction. It can happen. So this side is coordinated, so people are on this side are green, 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 and you are finding red, red, red. Okay, so it's not my fault. And in some cases, like you know about 16 December highway, when there's rush time, school time, your speed is like 10-20 kilometers per hour. So they designed the coordination for 50-60 kilometers per hour. So obviously you are going slower. When you reach the signal, you are late now. It was green, now it has become red. Okay, so we can do coordination, but it's not a guarantee it will work every time. Okay, because of the volume, because of the other conditions, it may not work. Okay, saturation, headway and flow rate, two very important terms for signal design. What we mean by headway? What is headway? Space? Time, yes. It's a time between two vehicles. Okay, and what is flow rate? Huh? Say again. Say again. Flow is less than 1 hour, and flow rate is turn into 1 hour. Okay, flow turn into 1 hour. That is flow rate. Okay. Saturation means what? Maximum. Saturation means maximum. Saturation flow rate means maximum flow rate. Saturation flow rate is maximum flow rate. If the flow rate is maximum, the headway is minimum. For maximum flow rate, the headway should be minimum. So when I say saturation flow rate, I am saying maximum flow rate. When I say saturation headway, I am saying minimum. Clear? Clear? Okay. The equation between them you can see on the board here. S is the saturation flow rate, H is the minimum headway. Now, saturation flow rate is the maximum flow rate for a signal without interruption, without any stoppage. Saturation flow rate is the maximum flow rate on a signal without any interruption. Okay. What did we say? Flow rate is vehicles per hour, right? Huh? But we have a signal. Can we have a signal? No stoppage, no interruption for 1 hour? Can we have this? No, right? Everybody agrees. Practically not possible. Maybe in your dreams, okay, or in paradise after you die, okay, but not possible. Okay, so it's a imaginary or theoretical value. Okay, it's not an actual value. It's a hypothetical or theoretical or imaginary value. Clear? Okay, saturation flow rate is an imaginary value because we cannot have 1 hour of green without interruption. So you can see, to find out saturation flow rate, I need what? Headway, saturation headway. Okay, how do I find out saturation headway? You go to a signal. Signal is red. You start your observation. What observation? Your observation will start when the signal will become green. Signal becomes green, cars start to move. So you have a stopwatch, you start measuring their headway. When the cars start to move on green signal, you start measuring their headway. But all headways are not to be used for saturation flow rate. Okay? The first 3-4 cars in the queue, so there is a queue of 10 cars, let's say. The first 3-4 cars in that queue, their headway is longer because they are going slowly, they were getting ready to move and so on. The drivers behind them, the 5th and the 6th and the 7th, they had more time to get ready, okay, complete their message, put their phone away and so on, and they had more time to accelerate as well. Okay, so their headway is lower. I am looking for that headway. Okay, the headway follows the trend which you see in the graph, this graph. Okay, so you can see the first headway is very high. Next one lower, next one lower, next one lower, and then it achieves a minimum value. I am looking for this minimum value. Okay, so you will do the observation of headway on the highway, on the signal, on the signal, but you will take the first headway, the second headway, third headway, and you will observe that they are getting lower and lower. Okay, so when they reach the lowest value, I am looking for that one, and it will happen after the 3-4 vehicles. After 3-4 vehicles of the queue. Clear? Okay. Once we have the headway, you can find out saturation flow rate. Clear? Okay. Any questions? Okay. The extra headway which is taken by the first 3-4 vehicles. You can see in the graph, this extra headway is denoted by delta. Okay. What is delta? The extra headway which is taken by the first 3-4 vehicles of the queue. Extra means more than the saturation value, more than the minimum value. The minimum is 2. So any headway which is more than 2 is delta. Any value above 2 is delta. Okay, clear? So you will have some delta in the first 2 cars, some delta in the next 2 cars, some delta in the next 2 cars. If you add all these deltas together, it becomes startup loss time, L1. Okay, what is L1? The summation of extra headways which are taken by the initial cars of the queue. Okay, the extra headway which is taken by the first 3 or 4 initial cars of the queue, their summation, the summation of the extra headway is startup loss time. Okay. Saturation flow rate. In every phase we have 2 loss times. In every phase we have 2 loss times. What is the phase? Huh? Green, yellow and all red. Yes. Okay. Green, yellow and all red is one phase. So in this time, when the signal was green and yellow and all red, in this whole time, there are 2 types of loss times, L1 and L2. What was L1? Startup loss time. Okay. L2 is clearance loss time. Clearance loss time. What is another name for clearance? Huh? That was changed. Clearance. What is another name for it? Huh? All red. Okay. All red. So all red is also called as clearance, and that is the loss time. Okay. That is the loss time. So every phase has startup loss time. When the signal just turns green, it has some startup loss time, and the signal becomes red, it has clearance loss time. Signal has 2 types of green: actual green, effective green. Actual green is capital G. Capital G is actual green, when you see the green light. So anybody with a stopwatch can measure actual green. Okay, you can measure it. See for how many seconds the signal was green. That is actual green. Then we have effective green. You can see the equation of effective green over here. So effective green is the time of the phase, a portion of the phase in which vehicles are moving at saturation headway. Okay, effective green is a portion of the phase in which vehicles are moving at saturation headway. The headway between them is saturation minimum. Okay, that portion of the phase is known as effective green. How do I calculate it? What was capital G? Actual green. What is TL? I showed in the last slide. What is TL? Total lost time. Okay. What is capital Y? Capital Y is yellow plus all red. Capital Y is yellow plus all red. If it is only yellow, it is small y. Only yellow is a small y. Capital Y is yellow and all red both. Clear? Clear? Any question? Okay. We have one example. We have a movement, an approach on the intersection, and it's a signalized intersection, and the data for that signal is given here. Total length of the cycle 60 seconds. In this, actual green time is 27. Yellow plus all red, capital Y, 4 seconds. Saturation headway 2.4 seconds. Startup loss time is given, clearance loss time is given. What is the capacity for this movement? What is the capacity of this movement? Okay. To find out the capacity, there are two methods. Okay. The first method uses the saturation headway. The second method uses the saturation flow rate. Okay. First of all, now I'm talking about the first method where I will use saturation headway. I'll use saturation headway. In the first method, I should know how many cycles I have in 1 hour. First thing I will calculate is how many cycles I have in 1 hour. So I calculate I have 60 cycles in 1 hour. How? How do I know I have 60 cycles in 1 hour? Because each cycle takes 60 seconds, so in 1 hour you can have 60 cycles. Okay? 3600 upon 60. Okay? Clear or not? Number of cycles 1 hour upon cycle length, which is 60. Okay? Clear here? This is clear? Okay. Then I will calculate effective green. Effective green was actual green, which is given 27 seconds, plus yellow and all red. Yellow and all red given 4 seconds. Plus, sorry, minus lost time. We have startup lost time and we have clearance lost time. Both of them are 2 and 2. Okay, so 27 plus 4, which is yellow and all red, minus 2 and 2, which is startup and clearance loss. Clear? So the answer is still 27. Plus 4 minus 4. Using, so in one cycle I have effective green of 27 seconds. This is effective green in one cycle, right? And how many cycles in 1 hour? 60. So how much effective green in 1 hour? 60 into 27. Clear? Total time is 1620. What is the definition of effective green? Portion of the phase in which what?
Vehicles drive at saturation.
Vehicles are driving at saturation headway. So the interval between the vehicles in these 1620 seconds is 2.4 seconds. It's given. Saturation headway is given. How much saturation headway? 2.4 seconds. Okay. So during effective green, the interval between each vehicle is 2.4 seconds. So 2.4 seconds per vehicle, right? 2.4 seconds per vehicle. And how many seconds total available? 1620. The total time divided by headway gives you the flow. This is the capacity. This is the capacity. Okay. So first thing, how many cycles you have. Then how much green time, effective green in one cycle. Then how much effective green in the whole hour. And divide by the interval, give you number of vehicles in 1 hour. Clear? Clear? Any questions? Okay. Next method. Yes. Effective green in 1 hour. Okay. Any other question? Okay. Next method, I said we will use saturation flow rate. First of all, I will calculate something which we call as G by C ratio. Effective green upon cycle length. Effective green, you know, you calculated already, 27. Cycle length given 60 seconds. So G by C ratio is 0.45. Okay? 0.45. 3600 divided by 2.4 gives you saturation flow rate. What is 2.4? Saturation headway, right? 3600 upon saturation headway gives you saturation flow rate. What is saturation flow rate? Maximum flow rate when what happens? Or without what? Without interruption, right? Okay. So the saturation headway gives me a flow rate of 1500, but this is not the capacity because my signal has interruptions, right? My signal has interruptions. Without interruption, what will happen? The entire cycle length will be green, right? Without interruption means what? The whole cycle is green. So this ratio will be 1. Okay, is it 1? No. So how much is my actual capacity then? The ideal value with full green multiplied by the portion of green I have, which gives me the same value. Okay? Clear? This is ideal capacity when you have full green. Full green means G by C will be 1. Okay? Full cycle is green. G by C will be 1. But actually, I have only 0.45 of the cycle as green. So I will have only 0.45 of this one. The actual capacity will be only 0.45 of this one. Clear or not? Clear, everybody? Any questions? Okay, all good? Okay, thank you.